Okay, I will continue with another example. Moment of the force. In Finnish, voiman momentti, and you can probably understand which word is moment and which word is force, so it is in the opposite direction. Voima is the same as force, and moment is the moment. Again, I letter in the end of the word. We get the Finnish word from moment. And I will first take again simple example. I will draw a coordinate axis here. And I will have a point there. I will choose, let's choose this point here, and this will be point A. The coordinates of that point is 2 and 4. This is X and this is Y. And then I have here a force vector. Let's say it will go which direction I will choose. I will take another color. Let's choose this blue color, and here we have the force vector. Let's say this is 4 kilonewtons, the magnitude of that force vector. And we need to calculate the moment of this force, calculated to the point A. And as you probably remember from the basic physics, that the moment of a force is calculated by multiplying the force or the magnitude of the force by the distance to the point in which we are calculating that moment. And that distance is measured from this is the shortest distance. So in this case, when my force vector is going there, I will draw the action line, line of action or action line, or the line which goes through that force vector there. Line of action of force. I will write that there. Line of action of the force. Force. And the shortest distance from this line to the point A is this here. And if we have a unit meters, let's say this is meters, these coordinate axes here, we can see that the distance from the line of action of the force to the point A is, in this picture, it is 2 meters. So it is easy to calculate the moment of force by multiplying the magnitude of force and the distance. So we get 4 kilonewtons times 2 meters. So moment to the point A will be 4 kilonewtons times 2 meters. and that will be 8 kilonewton meters, or kilonewton times meters. And the direction of this moment, we can see that if we have this point A here, the force is going there, and that means that it will rotate around the point A in this direction. So the direction will be like this. So this is the usual method to calculate the moment of force. We have magnitude and the so-called moment arm or torque arm, or the shortest distance from the point to the line of action. This is the usual method. But this method is almost impossible if you have three-dimensional space. For example, we have a force vector. This pen is a force vector, and it's oriented like this. And the point A will be, for example, this here. And this is in third dimensional. We had to find out the shortest distance to that point. That it is almost impossible to find out the shortest distance, or at least it is very, very tricky geometry to find out that. But the vector method is helpful here. And I first will calculate this example by using the vector method, and probably you can understand that when we have this vector product, tidal vector product or cross product, then we will use this method. Example 1 with cross product. I will draw another picture there, so I copy that picture here. I don't want to draw this to the previous figure, because it is we will do this a little bit differently. We have X and Y, and again the point A will be here in the same place, A, and the coordinates will be 2 and 4. And then we had this force here, which is oriented like this, 4 kilonewtons. And we had this line of action there. And in this vector method or cross product method, we choose whatever point from this line of action of force. We can choose whatever point we like. Actually, it does not matter what point I choose. Let's say I will choose I guess the most first thing you could choose would be the point where this force is attacked. So I will choose this. Let's call that B. But as I told, I did not need to choose that point. It is enough to choose whatever point in this line, which is the line of action of that force. But I will choose that, and of course many times it is most useful to take that point, but as I thought, it can be whatever point. And then I will create a vector which starts from A and ends to B. So I will choose this kind of vector here and call it vector R. This is the same as AB. So we see that the coordinates of this vector B in this picture, it is 4 and 2. So now this vector R, or the vector AB, is coordinates of B minus coordinates of A, so that will be 4 minus 2 and 2 minus 4, B minus A. 4 minus 2, 2 minus 4, that will be 2 and minus 2. And then the force vector here. Let's call that vector F. We can see that the vector has the magnitude, this force vector has a magnitude of 4 kilonewtons. That is the magnitude of that. And what is the direction of that force in this picture? We can see that it is going to the direction of positive x-axis. Positive x-axis is oriented to its direction is to the right in this picture, and this has the same direction. So it has the direction of the positive x-axis, and the unit vector I is the direction of positive x-axis. So the force vector will be 4 kilonewtons times I vector. And the moment A will be, we can use this method. No, of course, in this we also use the same method, but this was the first example. We made we calculated the cross product with the help of this determinant. And in this case, we calculate the cross product of R cross F. So this means we have a vector I, vector J, vector K in the first row. The second row will be the vector R, because it's R times F. So the first or the second row will be R vector. And in this case, these coordinates were in meters. I have to write it there. Here I have the unit of those coordinates. Those are meters. So this is also meters. So in this case, the R vector is 2 meters, 2 meters. I will use those units here because, minus 2, because I want to find out that I get the actual unit of moment, which is kilonewton meters, or unit of force times unit of distance or unit of length. Kilonewtons times meters in this case, kilonewtons times meters. So 2 minus 2 and 0, the third component. And this F vector we had here, it is 4 kilonewtons I, so that will be only 4 kilonewtons in the first place, and 0 and 0 in the second and the third column. So this is a determinant to calculate the moment vector R cross F. Okay, I will again copy the first two columns. 2 meters minus 2 meters, 4 kilonewtons, 0. I will use this method because I will give you later an assignment where you need to calculate the moment vector, and in that assignment you probably have not every coordinates are zeros there, or there are more non-zero components there in the calculation. But the method is the same as earlier. First we take this positive direction. We see that this first multiplication will give us 0 because there is 0 in one of those components there. Here again we get the 0 because the second component is 0 there. What about here? Again we get 0 because the third component there in the multiplication is also 0. So all these will give us zero vectors. So that will give us 0, the positive direction there. But then we have the negative direction, and I write the minus sign here, and then I choose this direction here. And here we can see we get the first one, which is not 0. We have 4 times minus 2, that gives us minus 8. And kilonewton times meter, that will give us the unit of moment, and there is K in the end of that vector. And what about the other ones here? Here is also direction of negative, or negative direction. Here are 2 zeros, so that will give us 0. And here the last one, there's also 1 0 there, so this will give us 0. So there was only one non-zero multiplication there, so and it was this minus 8 kilonewton meters K. And this minus changes the sign of that 8, so that will give us plus 8 kilonewton meters K. Or if I write this in bracket form, 008 kilonewton meters. Or if I take that unit away, that will give 008, and the unit of this vector will be kilonewton meters. Again, we can see from this example that here is the number 8. Here we calculated the moment of that force by using only this simple method, and we got the result 8. You can see it from here. Well, actually it is not the same as the number here, but because we need to calculate the magnitude of this vector. Of course it will be the 8, the magnitude, but I will write the calculation process here. Magnitude of, actually here MA, that this is also vector, there should be the line above that moment A. The magnitude of moment A will be calculated by using again the Pythagoras. So we get it like here, and the unit is kilonewton meters. And again we can see that it is square root of 8 squared, and this will give us 8 kilonewton meters. I earlier told that in the beginning of this example, I told that I could choose whatever point in this action of the line of action of this force. Whatever I choose the point B, but I could choose whatever point. I will calculate this with another way by choosing, for example, this point here. I'm not going to draw a third picture, but I will take another color. If I only find, is this another color? I will choose this point here, and this will be point C, and it is from this coordinate axis. I can find out that the coordinates of that point will be -3 and 2. And I can calculate this by using not vector AB, but vector AC. So I will draw this vector here. And this is now AC. And let me take another paper. If I can get that. Yes. Example 1 by using point C. So in this case, so what's that picture there? I have this vector C, point C there, and I need to find the R vector. That in this case it will be vector AC. I will take first coordinates of C and subtract coordinates of A. So that will give us -3 -2, 2 -4. That will give us -5 and -2. And this is meters, the unit of that vector. And we have the same force vector here. It is 4 kilonewton I. So the moment A vector we get by AC cross F. I'm not going to do that with the determinant. I will do this with a simple method right now. I will take the vector AC in bracket form. It is -5 -2, but with unit vectors it will be -5I -2J. This is the vector AC. And we multiply that with cross multiplication. We multiply with F, and the F vector will be 4 kilonewton I. Sorry, I forgot the units. 5 meters and 2 meters there. Sorry about that. Probably I will write this another 5 meters I -2 meters J cross 4 kilonewtons I. Let's not remember that at all. Sorry about my nasty notes. So how do we calculate this? We have multiplication with these. Actually, we can see that there is I cross I. In the beginning of these lessons today, we had these rules here. If we have I cross I, then that is zero vector. So I cross I, that will give us 0. I will write I cross I is 0 vector. So this will give us anything. That does not give us anything. Then the other multiplication here, we have j and I, and that will give us something. That will give us k, and here we can see j I with this figure. J cross I, we are going to negative direction, we will get k with minus sign. So this will give us j cross k, sorry, maybe this is Friday and I am already totally tired this week. Sorry about my mistakes. J cross I, that will give us, let's check that again, J cross I will give us as negative k. So this will be minus k. So there we have minus 2 meters times 4 kilonewtons, and then we get this, I will write it here, J cross I, and this will give us minus 8 kilonewton meters, and then this is minus k, which will give us 8 kilonewton meters k. So we got the same previous example. Yeah, we got the same result as we got when we used the point B there in the picture. Even though the vector R here R was oriented to right and downwards, and in the second example we had R vector which was oriented to left and down. So totally different vectors there. This force vector was the same vector, but these R vectors were different vectors, but still we got the same result. So this gives us possibility to choose the simplest possible vector. And for example, there we could choose that vector because zeros are always good ones. If we have in cross product, we have zeros in the calculation. For example, here we had many zeros. We got many zeros from the multiplication. Then we could, of course, choose the vector R so that we get most easy vector. And for example, in this case, we could have chosen the vector which goes downwards, because that will give the R vector a component of 0. And in this case, we did not have any, for example, if he had this vector, if that would be point D there, then the R vector would be downwards, so that will be oriented to negative y-axis. So there is no I component at all. So this component is taken away there, and in that case we could find out the moment vector by simply multiplication of these two numbers. So that will give us more easy one product. But actually, as I told in the beginning, or in the beginning of this example of application of cross product, in the moment calculation of moment of a force. This method is most useful when we are considering or having a force vector which is oriented in third dimension. So it is not oriented, the force vector does not act on plane xy, because as we see, we could find out that method with simply by watching this picture. We get 4 times 2, that gives us 8. But when we have third-dimensional and three-dimensional forces, then we actually don't have any other easy methods to find out the moments of vectors, for moments of forces. We don't have any simpler method than this vector product method, which we can solve, for example, by using this determinant we had here. So I have given the assignments to the 15, to assignment 15, and that will they are there in the Moodle. I will add there also an assignment which is which considers this moment application. There are some assignment which you have to find out the area of triangle with the help of vectors, and I have told, and there in the Moodle you can see that the total amount of those assignments in this course will be approximately 24. I can say that the maximum amount is 24, and that means that if you are calculating how many assignments you need to pass the course or complete the course, the 1/3 of the maximum amount is the limit of grade 1. So that means that at least if you can at this point, at that point when you have solved the 8 assignments correctly, then you have achieved at least the grade 1 in this course. But I will add at least one assignment which is still this vector area, and the last ones will be assignments which consider matrix calculus. But I don't actually know yet what will be the total amount of those assignments. But I have given the maximum number will be that 24 in this course. But sorry about these mistakes I made in many examples today. I'm very tired this work week, but I hope I can relax during weekend. But I will end today's lessons to this point, and I hope you wish you very good weekend, and you can send me those assignments when you get solved. I don't remember if I have something not checked you have sent to this point. Some of students in this course have sent me some assignments which I have not had time to check, but I try to check them during weekend. Okay, but I wish you a good weekend, and let's see, probably on Monday we have next lessons. So bye for now.